Welcome back friends, welcome back in another video tutorial for microbiology with Shagnik. So in this video tutorial we will going to talk about how to calculate the charge on amino acids as well as protein. Okay, so let's get started with the video friends. So first of all I want to mention that the charge calculation of protein and the charge calculation of amino acid is mainly dependent on the pH. The pH of what? The pH of the solution in which that particular protein is present. If the pH of the solution is acidic, then the charge of the amino acid as well as the charge of the protein will be different. If the pH is neutral, then the charge on the amino acid as well as protein will be different. And similarly, if the pH is basic, then the charge of the amino acid as well as protein will be different. Okay, so let's consider the first situation when the pH is acidic. Let's suppose a situation you are taking a protein which is in a acidic environment. Okay, so if your protein is in acidic environment, make sure the environment of the protein is enriched with H plus. Okay, and if it is, remember NH2, which is present as a basic structure of amino acid, as well as it is also present in the R groups in case of basic amino acid. So in presence of too much amount of H plus, this NH2 will be protonated. Okay, that means it will be converted into NH3 plus. And in case of COOH, that is our carboxylic group, what will happen? There will be no kind of protonation. Okay, so in acidic pH, NH2 become NH3 plus, COOH remains COH, and we will have to consider three kind of R groups. One is COH, NH3 plus, another one is the R group which is present in cysteine. So here also only NH2 will be protonated and the remaining two will be same. Okay, so when the pH is acidic, make sure that NH2, no matter whether it is in basic position or whether in its R group, in both the cases it will be protonated. Okay, similarly, let's make a condition when the pH is neutral, that means pH is 7. Under such kind of condition, make sure that COH will going to donate the proton. Similarly, NH2 will going to take a proton. That means COH will be deprotonated and NH2 will be protonated. Okay, so that is the thing. So under such circumstances, the primary groups will be CO minus and NH3 plus, and R groups will be CO minus and NH3 plus. Here also SH is intact. Okay, there is no change in SH. Now let's make another condition where pH is basic. Okay, as I have told you, if your protein is in an environment which is basic, that means the protein is surrounded by OH minus, right? There is too much amount of OH minus here. Okay, under such circumstances what will happen? Remember, COOH will going to donate proton. Similarly, NH3 also will going to donate proton, and here interestingly SH will also going to donate proton. Okay, that means COH will going to be CO minus, NH3 plus if there is in, then it will be going to convert it into NH2, then CO minus, NH2, S minus. Okay, and the protons that they have donated will react with the OH minus which is present in the environment and convert those OH minus into water. Okay, so that is the idea how the charge of amino acids as well as protein varies depending upon the pH of the solution where it is present. Okay, now here we are taking an example which is this one. So now understand it very carefully how I will going to solve. So they are telling us to calculate the charge of the peptide on pH 1 as well as pH 7. Although I have already calculated it, I will going to explain it how I have calculated it. So first thing is to determine the N terminal and C terminal. I have already told you how to find out N terminal and C terminal. N terminal of the peptide is the terminal where there is a free NH2. Okay, and as you can see on your left side there is a free NH2. So it is your N terminal. and C terminal where COH is not involving in any kind of peptide bond formation, right? So this is your C terminal. Clear? Now your second job will be to ignore all the diprotic amino acid. Okay, so diprotic amino acid means where only one NH2 and COH present. Okay, so remember, except basic amino acids, for example, our lysine, arginine, histidine, acidic amino acids, for example, aspartic acid, glutamic acid, and tyrosine, which contains OH group as in its R group, and cysteine, which contains a SH in its R group. Except these two type of amino acids and two amino acids, all the remaining amino acids are diprotic amino acids. So if you are finding something except these four things, make sure that all they are diprotic amino acid. You have to ignore them. Okay, so this is the step number 2. That is why I have ignored here glycine, phenylalanine, alanine, as well as methionine. Okay, now you have to find out the amount of pH or the value of pH in which condition they have told us to calculate the value of the peptide. So here the condition is pH 1, that means highly acidic, right? And highly acidic means too much amount of H plus in the environment, right? So under such circumstances, what will happen? All the NH2 will becomes converted into NH3 plus. So here is a free NH2 present, right? It will be converted into NH3 plus. Okay, now we have to calculate the condition in case of tyrosine. So OH will not be protonated, so OH will be remain intact. Okay, and COOH in case of pH 1 will be intact, right? So only 1 plus charge, that is why in case of pH 1 the charge will be plus 1. Now let's consider another situation. They have told us to calculate the charge of the peptide at pH 7. Okay, so again we have to ignore the diprotic amino acids, then we have to mention the N terminal and C terminal. Now in neutral pH, what I have told you, that the basic chains or basic side chain or NH3 will be protonated, and acidic side chain or acidic or COOH group, let's consider, which is at the primary position, will be deprotonated, right? So NH2 will be NH3 plus, COOH will be CO minus at pH 7, right? So plus minus will cancel each other, and OH will not be protonated or deprotonated, so there is no charge present. That is why at pH 7 the charge will be 0. Okay, so that's how you can calculate the charge of any peptides. But I want to mention it very very carefully. Please take care about the pH they have mentioned. If they are mentioning acidic pH, then make sure that all the NH2 will be protonated. If they are mentioning a basic pH, then make sure that NH2, if there is NH3 plus, then it will be deprotonated. If there is COH, then it will be again deprotonated, right? So that is the idea. Okay, so I hope this video will be helpful for you. Now you are able to calculate the charge on proteins or peptides. So I hope this video will be helpful for you. So thank you for listening to this class.